This short video is an introduction to the research being done at the Combustion and Catalysis Laboratory located at City College. I am Professor Marco Castaldi. I direct that laboratory in collaboration with my graduate students, engineers, and postdocs. In addition, I am the director of an international organization wholly located at City College, the Earth Engineering Center, which I'll give you a little bit more information about. And I am the U.S. director of an international organization called the Waste to Energy Research Technology. A little bit more introduction about me. I bring to the academic world a collaboration of industrial research and background and rigorous academic research. Prior to coming to academia, I worked in industry for about 10 years as a fuel processor, catalytic development engineer and manager, and worked on catalytic combustion development and was awarded about 9 patents. After coming to academia, I maintained in industrial collaborations where I periodically go to industry and do research there with them. In addition, as you can see in the technology development, we have a number of industrial researchers that provide us with applied problems that they have and fund our research. During my PhD that I received at UCLA, it was in chemical engineering. It focused on high temperature chemical kinetics, and primarily that was combustion of flames and understanding the mechanisms and dynamics of combustion systems. But my time at UCLA was sponsored by an EPA Pollution Prevention Fellowship, and that was the first time that I had been able to combine the idea of hardcore combustion and rigorous understanding of those combustion processes with an application toward a real problem, pollution, and what kind of solutions that could be applied to that in terms of understanding the mechanisms to prevent pollution in the first place. So in general, the research that's done over at this Catalysis lab is focused on, in general, catalysis and combustion, and really works to be at the interface of environmentally benign energy technologies, whether that's understanding them or improving them. You've seen some sponsors of the research that we have over at the Combustion Catalysis Laboratory. Some other sponsors range from large companies and organizations, Covanta, BASF, the American Chemistry Council, and HDR and Waste Management, to smaller organizations such as the Environmental Research Education Foundation and smaller companies like Innoveering and Magato. And so our research basically is sponsored by, I would say, 50% industrial sponsors and 50% the typical government agencies and other types of research institutions. Looking at the type of research that we do at the Combustion and Catalysis Laboratory, you can consider all of the projects and applications that we work on falling under these 4 boxes, and they all fall within a general box that basically tries to take resources and/or waste materials from the environment and put them through various processes or technologies that will result in outputting something useful, such as energy, electricity, and heat, and releasing emissions or things into the environment that are much more benign and less impactful than what we started with. Classic example would be taking waste materials, converting that to energy, yielding electricity, and what goes out also into the environment in terms of emissions is an ash that could be used as an aggregate, and CO2 and water. Working at the Combustion Catalysis Laboratory will provide you with a great experience. We've got a great team that you can sort of see here, quite international and varied in range of experience and interests. We have a number of collaborators that we accept international scholars into our laboratory. And what we like to do is make sure that the students get an international or a experience out of the lab, whether that be domestic or international. You can visit the website to see more of some of those activities that the students take on. The main focus that we work on is really thermal and catalytic conversion of carbon-based materials and try to get that to desired products. The Earth Engineering Center is a sister lab that we started about a decade ago. And here what we're looking to do is take the fundamental research that we do at the Combustion and Catalysis lab and bring that to what we consider engineering solutions. And that's what we work very heavily with companies. And it's not necessarily focused only around waste materials, but what we really try to do is take a creative, realistic approach to make forward-looking applications work or understand these forward-looking applications. And fortunately for us, we really have an international collaboration that allows us to stay on top of the activities that occur globally. So in overview, the Catalysis and Combustion Laboratory focuses on catalytic and homogeneous research. We're always at high temperatures, and we mostly focus on carbon-based materials. We have projects that always are at the intersection of fundamental yet practical real-world situations. And again, all of the students and even engineers that come to work at the CCL have had external collaborations with laboratories within the US or around the world that range from 1 month to a year. We work with large companies, global companies, Veolia, BASF, as well as local companies like Covanta and American Chemistry Council. And importantly, it's not just these industrial companies that we work with, but also institutions such as the US Environmental EPA, the United Nations, the International Solid Waste Association, but also local agencies like the Department of Sanitation of New York. The experience that a typical graduate student would get is primarily 80% experimental. They have to sort of build and construct their own individual systems, whether that's a reacting system or putting together a number of analytical techniques, mainly develop reaction engineering combined with analytical skills. And importantly, since the research is about 50% funded by industrial sponsors, I ensure that the students and engineers working on those projects are the ones that are reporting out, interfacing, and meeting with the sponsors during phone calls or on-site meetings to make sure that there is that real exposure to the researchers in these companies. So at the end of an experience at the Combustion Catalysis Laboratory, you definitely develop leadership skills, not only working with new graduate students or engineers coming in, but also on how to interface and work with customers at an international level. Over the past 15 years, I've graduated about 20 students, and a very tight average is about 4.5-year completion with about 4 papers published. Very quick example of how our research is at the intersection of fundamental and applied is this hydrodeoxygenation of biofuels that was sponsored by BASF. One project that we were given was, how do you take biomass and make gasoline? And when you look at the chain of how that occurs, what happens is you have oxygenated hydrocarbons and sugars and alcohols that need hydrogen addition to make gasoline. And one of the places that you can get that hydrogen is if you pull off some of these intermediate chemicals and gasify them or reform them with water, you can make hydrogen. So one of the questions we were asked by BASF was, what would be the catalytic process that could be used to make steam reforming of these types of chemicals to produce hydrogen? And we took a case chemical called ethanol, where it had the carbon-carbon, carbon-oxygen, hydrogen-carbon bonds to give us a real idea of how all of this would work. And one of the reasons why they wanted to understand what would be the catalytic process and what is occurring in that catalytic process is to take a look at this chart here. Here we have mole percent versus runtime in hours, and let's just focus on hydrogen. What BASF had observed was that for a certain amount of time there was a steady performance of hydrogen output, but then followed by an initial deactivation. After regenerating the catalyst, they were able to reestablish that performance of hydrogen, but only for 8 hours. But then again, it started another deactivation similar to the previous one. And as continued regenerations occurred, it was possible to get back that initial activation, but that plateau of stable operation eventually disappeared. And the question was, what is happening? And more importantly to BASF, how can we ensure stable operation? So what we looked at was first to say, well, instead of waiting for the catalyst to deactivate and then regenerate it, what would happen if we started a regeneration cycle prior to the catalyst starting to deactivate? And that's what we did here. You can see here, this regeneration happened at about 30 hours, right? Deactivation started at about 20 hours. Well, in this case, what we decided to do was just do regenerations every 5 hours and see if we can maintain constant hydrogen production. And we were. So for BASF's perspective, that was an excellent solution. Every periodic 5 hours or so, regenerate the catalyst, they could have steady production of hydrogen. But from our perspective of the CCL, the question was, what can we try to elucidate to understand what's happening? Why does preemptive air treatment delay or prevent deactivation? And in order to do that, we went into a isotope labeled ethanol, where we labeled it with carbon-13, and isotope labeled water with oxygen-18, and basically was able to track how the ethanol decomposed on the catalyst and produced different products that then yielded the final output of the continued hydrogen production or the deactivation. What we were able to uncover here is that the initial activation was a carbon-carbon breakage, but that deactivation that was irreversible was when there was a carbon-oxygen breakage, and that carbon stayed on the catalyst surface and basically started a carbon buildup. And that paper's been published, and you can read that, and you can see our website with a little bit more of this. Typical journals that accept our research range in impact factor from 1 to 12. Impact factor for us is less important in terms of the community that we work with. So the catalysis journals that we publish in are Applied Catalysis, Catalysis Today. A lot of the combustion work that we do is in waste management, environmental science and technology, and science of the total environment. But we also publish in energy and fuels, fuel, and INECR, which again is focused on the community that the research would be most applied to. So hopefully this gives you a nice introduction in terms of research that's going on at the Combustion Catalysis Laboratory and the Associated Earth Engineering Center. Look forward to your application if you have interest, and if there is any further interest, please visit the websites that are on these slides, but feel free to reach out and send me an email, and we can set up a separate conversation. Thank you very much.